Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Towards Credible News, developing a system for rumor and non-rumor classification using deep learning. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. I am Deepak. Today I am here to present you one of the application, the research domain that we are covering by using the artificial intelligence deep learning architecture for detection of the rumor and the non-rumor content. So this is basically related to the NLP and for the real-time applications. So here the deep learning has been used. So before moving to that, what we have developed into it, so let's talk about that what we will cover into this video. In this video, initially we will talk about in which application areas the developed system will be helpful. Other than that, the code that we have designed, how to execute it, what are the software requirements for it. Next to that, we will talk about what are the current systems and what are the issues in that, and what proposed system is doing, and the main contributions of the work. Finally, and experimental outcomes and findings will be discussed. So let's talk about the application areas. The developed system is specifically designed for detecting the fake news by detecting the rumor or the non-rumor content from the given data sets, and specifically by detecting the fake news we can save our social factors in handling the spread of the fake news. Other than that, this developed systems is helpful in many of the NLP application, like for the email filtration, for smart assistants, for analysis of the documents. Other than that, for the social media platforms and the chat bots and many other scenarios. So this is the need of the current systems, though, where people are engaged in every of these application areas. So a solid and effective solution is required in order to detect the rumors from the given data. So let's move to the main work done. So let's talk about how to execute the code. So we will give you this folder named code, under which all the files has been placed. So the whole code is being designed into the MATLAB. So you must have the MATLAB software with you, under which 2019 version that I am using. So you can use 2018 or the higher version, but make sure the MATLAB should be the full version or the trial one. So in order to run the code, you just need to go to the folder and just copy the path of the folder. So you just click here, copy, and then go to the MATLAB and just paste it. When you will press enter, you can see all the files those were there in the folder can be seen here. Out of this, you need to run this main code file with you, under which the whole code has been written. Now let's see the data related to the data set. So data set is related to the information which are labeled as a rumor or the non-rumor. We have given this text document under which the links have been given for the rumor and the non-rumor data set. So you can just copy it and go to your web pages from where you want to get the information. So I do have this link, you can open it. For example, one of the dataset link is here. From here you can directly download the file, and every information related to the what kind of rumors have been given into it, it is over there. So other dataset is here and third one is here. So you can work with multiple datasets also. So dataset that we are using is given here. You can see all this information is like IDs, whatever the text is given, when it is created, along with the labels that it is a rumored or the non-rumored content. So we are using the information directly instead of working with that. So in order to run the code, you just need to select the file and click on the run button. It will start executing the process. Now let's talk about that, what people are doing and what exactly we are doing. We are using this space paper as a reference for the developed system, where they have designed one of the system using the providing the CNN network, and by using the CNN network they have compared it with the existing method. So they have given this name as a topic driven rumor detection. So according to the data, they were identifying the source of the microblogs, and then they were automatically performing the classification on those sources. And finally, the model that they have present was a CNN model, under which they have given that what CNN model they have given and what are the filters and all that stuff. So the issue that we have find from this is like they are working with the basic model of the CNN. Advancement in the CNN is still possible, and an advanced system for the CNN can be given in order to handle the text. Secondly, uh, the methodology must be to see that if the data is not processed and directly given to the network, because deep learning are efficient enough to work with the data set without extracting the feature, to see if the real time data can be given directly, that how it perform. So that is the another contribution of our work where we are working. So the code is running, let it be completed. In the meantime, let's talk about the code. So in the proposed method, what we have done initially, we have read the data set and separated the information. Initially we have given the histogram of the labeled information in order to get the data that to each class how many content or the information set has been with us, which gives us the frequency of data available in the both classes. Later on we are partitioning the data with the 80 and 220, where the train data and the validation data has been separated. Then we are not doing any pre-processing of it, only converting it from character to the numerical one, so that the system can be effectively understand the patterns. Then we have designed a CNN network in which basically three of the sections has been implemented with the convolutional batch normalization layer and the ReLU layer, where the size has been given as the 8, 16 and 32. And then on that behalf, the further classifiers information is on the batch size of the 64. SGDM learner is being used along with the initial learning rate of 1 e raised to power minus 3. So all these features has been set by the proposed CNN model with a higher score. So then finally the validation has been performed, and results has been evaluated in terms of four factors, that is accuracy, precision, recall and F score. So the main contribution is proposing a new CNN model with providing the different layers in order to get the better results. Secondly, providing the data without the pre-processing, only converting it from normal scenario to the numerical scenario, so that we can evaluate that deep learning how perform to the actual form of the data. So lastly, we are calculating with the actual and the predicted outcomes. So the outcomes that we have performed with one run is accuracy of 80%, precision, recall and F1 score is in front of you. If I'm rerunning it, it will obviously consider that might be it will get the high results. So this is the initial phase where the frequency was given. We have also drawn the word cloud of the database for the rumored data and the non-rumored data. So this is related to the rumored one. This is during the training, where the factor that we have considered for the training is like RMSE and the loss, though both should be reduced as per the iterations must be increased. Even many other factors can also increase the accuracy of the learning, right? Increasing the epochs, changing the learning rate and many other things. Finally, the parameters those we have achieved from the proposed simulation is like this. Here accuracy, precision, recall and F1 score has been plotted, and finally we have compared it with the actual and the predicted outcome. So you can see the frequency for the rumor detected are more, where the non-rumor are less. So that is why the accuracy is not up to the mark. Here we have achieved up to the accuracy of 80% only. So if I'm running it again, so let's see that if we are getting any higher accuracy with the system, because the learning rate every time the batch size is being changing, which gives us the chances of getting the better results. So we need to retrain the models again and again in order to get the best outcomes with the accuracy and other factors, so that we can impose and we can just use those best trained model in the real time scenarios. So let's wait the iteration to get completed. We just reached to the second epoch. We have entered the 10 epochs. So let's see what accuracy we are achieving this time by retraining the model with the same data set without changing anything in the code. So it also depends upon the data set and the model that you are giving, and on that behalf the system get you the final outcomes. So let's see the system to get finished with the epochs. So you can see as the iterations has been increasing, every time the RMSE and the loss is reducing, which is a better sign for getting a good accuracy. So let's see what we will get after all the iterations. So it is still working. Out of 610 total iteration, 398 have been done. Epochs are basically a set of the iterations in every epoch. So total of the 10 epochs are there, and it is having 61 iteration in each epochs, so you can get the information here. So out of 10, 9 of the epochs has been done, 10 is under process. So let's wait for it to get finished and we will see what outcomes we will achieve this time. So it is about to be finished, only 10 of the iterations are pending, so it is done. So the results that we have achieved in our scenario is now reduced to 77. So every time when you are training the system, so this is more about the analytical model, because the data set is not processed with any of the vectorization or tokenization. So the variation among the data set is expected. So best network we have saved with the different runs. So you can see if I'm loading the best network here, for the before the classification, we do have this net with us. I'm just commenting it and running it again. So let's see if our model is effective enough to get trained again and give us the better results. So this was the model that we was showing that how the network get trained, and we can save it with us, and then run that I'm doing right now. It will give us the real-time outcomes, that how our system get trained and how it performed. So let's the epochs to get finished. This time it is a bit faster, because depends upon the what set of data is given at the initial stage for the training, because it is selected by the code itself. So 260 iterations has been completed out of 610. Around 300 has been done, so 50% of the epochs are completed. It is still running. So this is the third time run we are performing. So let's see what outcomes we just received, so that we can understand by running it again and again, the outcomes are expected to be better or worst, depend upon the data given at the initial stage. So 9 of epochs are done, 10 is going to be started. So 10th epoch is started, and the last 61 iterations are under process. So let's see what output we get. This time the accuracy achieved is 75. So every time you train the network, the results get varied. So further modifications are still possible into it. So for those details, you can contact us directly and can implement in the real-time scenarios for the research purpose and all that stuff. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.